Alright, in this video we're going to talk about hydrogen and just what happens in a hydrogen atom when energy is added. The first thing that we see can happen here is with this illustration is that when energy is added to a hydrogen atom, electrons will move from what's known as the ground state energy level. That would be the energy level, the 1s energy, or the first energy level, the s orbital, that's located on the first energy level. We'll jump to a higher energy level. In this case, this is a second energy level, so 2s, or it could be 2p. And jumping up, it now has more energy, and it's known as being in the excited state. It will eventually come back down to the ground state, but to do so, it must release energy. Think about a book falling from the top of a shelf. When it hits the ground, energy is released. As the electron falls back down to its ground state, energy is released, and it's released in the form of a photon. Sometimes we can see that photon, sometimes we can't. Okay, so we know from earlier, our video on electromagnetic radiation, that different colors of light, here's blue light and blue photons, have different energies. Blue light is the highest energy of visible light, or actually violet is, but blue and violet are the higher energies. Red light, which is of a longer wavelength, is the lowest energy. Okay, so based on the light that's given off, we can tell the relative energies between electron transitions. That's what you call it when an electron goes from one energy level to another. It's known as an electron transition. So if we have a sample of hydrogen atoms here, so here we have a bunch of hydrogen atoms, and we add some energy, similar to the flame test that you will do in this unit. By adding energy, either in the form of heat or electricity or some other type of energy, some of the atoms of hydrogen become excited. When they become excited, they then will go from the excited state. The electron will go from the electron in the hydrogen atom will go from the excited state to the ground state, and we get a photon being released. So the excited atoms emit the photon and they return back to their ground state. So with that in mind, this is a situation when we look at a hydrogen atom. There are multiple energy levels available for the electron to jump to. Here's the first energy level, the second energy level, the third energy level, the fourth energy level, and so on. It can keep going. And you can see that the electron does not necessarily have to jump just from the first to the second. It could jump from the first all the way up to the fourth, or from the second up to the fifth. When the electron comes back down to a lower energy level, from an excited state to a lower energy level, the bigger this jump down, the higher the energy that is emitted. And if you remember that light, the energy content of light, of photons of light, is best indicated by the color of the light. So that means that the bigger jumps should give us a color like, say, purple, which we see here. This is something called the atomic emission spectrum for hydrogen. This is known as an atomic fingerprint. Every hydrogen atom in the universe will give this same pattern of color, of lines. These are called spectral lines, so that we can identify, for example, the gas that's burning in the stars in faraway galaxies. If we look at this light through a diffraction grating, which is a device that's simply a piece of material with many lines spaced very close together, and this is called a diffraction grating. It allows light to be split, much like it would be split passing through a prism. A prism, not a prison. Yeah, that's where the light goes when it's bad. Bad light. You broke the speed limit. Go to prison. No, when it passes through a prism, a diffraction grating will split it up and give us these lines. We'll do this. You'll do this in class, so you'll get to see this. It's very interesting, very cool. But hydrogen, so here's a high energy transition, right? So maybe that will be this transition. And here's blue, a little lower energy. So maybe that's just this one. And then here we get green, we're getting less energy, maybe that's this transition. And then here we have red, which is low energy, so maybe that's this transition. And so for hydrogen, we see the atomic emission and we see where it comes from. Have fun with the SSS. Make sure you look over it, and copper tomorrow.